We will now look at 3 isotopes of silicon in order to calculate the atomic mass of silicon. We must remember, atomic mass is not the same as the mass number. The atomic mass is the average mass of all the isotopes that exist of a single element. So on the periodic table, the mass that we see on the periodic table is the average mass of all the isotopes that exist of that element. So for the element silicon, there are 3 naturally occurring isotopes of silicon. 92.13% of the atoms of silicon exist as silicon-28. And the exact mass of silicon-28 is given here. So you have this on your slide. So if you can't see this too well, you can visualize it on your lesson slides, okay? But I'm going to talk through it all and go through the calculation with you so you understand how to apply this. So the most abundant isotope of silicon is silicon-28, but there also exists silicon-29 and silicon-30. So I like to think of isotopes much like bowling balls, okay? So bowling balls all have different masses, but it's still the same function, it's still the same use. You're still going to use it as a bowling ball, okay? So an isotope of an element, it's going to be the same element, except it just has different mass, okay? So silicon-29 is 4.68% abundant, and silicon-30 is 3.09% abundant. So how do we take the average of these masses? And we need to take into account the percentages. So the calculation that you're going to do is take the mass of each isotope and multiply it by its percentage, the percent abundance, and then add them up. That will then give you your atomic mass. So what I'm going to do is I'm going to take this mass of silicon-28 and multiply it by the percentage as a decimal. Okay, so in order to make a percentage a decimal, we divide by 100. So the decimal percentage, well, the percentage as a decimal will be 0.9213 times the mass of silicon-28, which has been determined to be 27.9763 AMU. Do the same thing for the other 2 isotopes. So for silicon-29, that one is 4.68% abundant. So we're going to multiply this by 0.0468. And then when you multiply this, you're going to see that this will be 0.0309 as a decimal. So now once you have this, we're going to solve each one of these and then add them together to give us our atomic mass. So if you take, let's start with silicon-28, 27.9763 times 0.9213. This is going to give us the portion of the atomic mass that exists as silicon-28, which will be 25.774. We have a lot of digits here. Okay, so let's see. The rules for multiplication says to keep the least number of significant figures. The least number of significant figures here is 4. So we're going to multiply here and round to 4 significant figures. So this will be 25.77 AMU. Okay. Now, when we take 28.97649, multiply that by 0.0468. So now for silicon 29, there is 1 point, let's see here, we'll do 3 significant figures from the percentage here. So 1.36 AMU, 1.36 AMU, and then when we take 29.97377 times 0.0309, you will get, you'll get 0.926. We do 3 significant figures, 0.926 AMU. All right, so once you've figured out the percentage of each of the individual masses that make up the atomic mass of silicon, now we're going to add them together. So now the rules for addition says that we're going to keep the least number of decimal places, okay? So this may be difficult to read. So this is 25.77 AMU for the silicon 28, 1.36 AMU for the 29, and 0.926 AMU for the percentage of silicon 30. So now let's add these together. What I'm seeing in my calculator is 28.056. So what that means is that we're going to round this to 28.06. 28.06 AMU. And you should notice that this mass is fairly close to what is expected on the periodic table. So let's see. So now on the periodic table here, if we click on silicon, we will see that silicon has an atomic mass of 28.085. So our calculations turned out to be pretty darn close to the exact mass that we find on the periodic table.